project. How it determines the feasibility of the project, that a project is feasible or not, we should invest in this particular project or not. And it also identify the risk associated with the project, which is also known as viability of the project. And how it calculate the deviation in the cash flow from the mean of expected cash flow. As we know, this normal distribution curve, deviation around the cash flow, okay, or we can say deviation around the mean is there, and this is a bell shaped curve, okay. So it gave us this deviation also. And Hiller's model analyzed the cash flow in two situations. What are these situations? First is correlated and second one is uncorrelated. Correlated means the result of past year affect the future result. How? We can take an example of any project. We can take here an example of consultancy or a web development project. If company does well in the past, customer are satisfied, then customer will continue to give project to the same consultancy company. Why? Because customers are satisfied with the past record. They will continue in the future also. So future sale will be increased on the basis of past record. On the other hand, if past record is not well, customers are not satisfied, they will not go to that particular company for any project or consultancy again in the future, and it will affect the sale also, right? These are correlated cash flow. In the next slide, we will try to understand why correlated is risky. And what about uncorrelated? Uncorrelated, as its name suggests, cash flows are not correlated, means no relation is there in the past and future. And this could be a case of a freelancer, okay, or when new product is in the market, new company is there, new market is there. So these are the uncorrelated type of cash flow, okay. Yes, how a Hillier model helps to interpret the risk in the project. How we can calculate, first parameter is NPV. We can calculate the net present value of any project, and when with the use of formula we calculate and we get the positive NPV, it indicates that outflow is greater than inflow. What is inflow? Inflow is initial investment, the amount of money we have invested initially for starting of the project. And outflow can be the total revenue, profit, sale. Obviously, when revenue is greater than investment, we will take this project. On the other hand, if it is negative, this means that outflow is less than inflow. The amount we have investment is greater as compared to the revenue. So we will not take this project. We will not invest in this particular project. Okay. The second parameter is standard deviation. What standard deviation give us? It is used to identify the element of risk. Deviation means what? Variability. So obviously when there is positive value, or we can say higher value, if we compare two standard deviation, suppose 5.1 and 7.1, both are positive, but this one is lesser value, this means this is less risky because less variability is there. Okay. On the other hand, negative or lesser value is less risky, and positive and higher value is more risky. Okay, so we will not take this project, we will go for this project. So what we can conclude? We can conclude that the higher amount of NPV and lower amount of standard deviation of the cash flow, we are dealing in cash flow of the project here, is less risky, least risky or minimal risky as compared to what? The situation when NPV is lower and expected standard deviation is high. Okay. In the next slide, we will discuss about the applications. What are the area where Hillier's model is applicable in? First one is investment decision. We can use the value of NPV calculation and standard deviation to decide we should invest, accept or reject a particular project. Second, we should continue the existing project or we should take the abandon decision, means we cannot continue with this. We have to leave this or we have to stop this. Okay. Third one is help in finding the probability of getting profit, loss, or BP is what? Break even point. What does this point known as? This is no profit, no loss point. Okay, so this will help us to identify that if we invested this much amount, what will be the NPV, what will be the standard deviation, what is the probability of profit, or for example we can take the what is the probability of earning 30 lakhs, what is the probability of getting zero loss or zero profit. We will solve it in the numerical. Last but not the point, least point is that we can justify that correlated cash flow is more risky than uncorrelated cash flow. Okay, how? When we calculate the value of sigma, that is standard deviation of correlated cash flow, and compare it with the non-correlated cash flow, which one will be greater? Obviously this correlated. Okay, this will be greater. So we can conclude that standard deviation is higher, variability is higher, risk is higher. Okay, and in the next slide I will tell you why we are using sigma for correlated and sigma square for uncorrelated. Okay. Yes, this is the formula which we will going to use for the uncorrelated cash flow and correlated cash flow. NPV is same in both the cases. If you have noted this, C is what? Cash flow. Okay. Time varies from 1 to n. 1 plus I to the power is what? Discounting factor. Why we are taking this discounting factor? To identify the present value of money. Okay. Because 1000 of this year will not be same as the same amount in the year 5 years later. Okay, why? Because time value of money changes. So we are considering the in discounting factor here, and we are subtracting it from the initial investment. Why? Because this is the amount of money we have already invested in. Okay, so we will calculate NPV in this manner. I hope this is clear to you. Now the sigma. We have to calculate sigma standard deviation. Here we are taking simple formula in the correlated cash flow. Sigma 1 plus t, sorry 1 plus I to the power t. Okay. And this is the simple formula that we are taking the standard deviation of every year divided it by the discounting factor. Clear? But why we are taking here sigma square? Because sigma square gives us the area. This is known as variance. I hope you all know. Sigma is known as what? Standard deviation. And sigma gave us exact value. And this gave us what? Area. In the meter square we can say. It gives us the exact value. Okay. So as we know, correlated is more risky. So we have to find the exact value here. Okay. For sigma. And it is lesser risky uncorrelated cash flow. That's why we are using sigma. It gives us the dispersion. Okay. So as we are using sigma square here, we have to take the under root, this 1 by 2. And similarly, in the denominator, 1 plus I to the power, instead of t, we need 2t here. Okay. So these are the formula we will going to use in our numericals. Okay. So please learn this formula and understand the concept of this. These are few numericals which I have taken. These slides I have taken from the Google, and I will upload this PPT in my classroom for my students. And these are the slides which I have taken from the course of project management I have done from IIT Roorkee, Professor Barua. And this is also very good slides. That's why I'm using this for my students to solve the numerical. Okay. Thank you so much.